Good evening, doctor. So for this video, I'm going to present about the tutorial on how I train the speech emotion recognition model and also how to use this model for future. So for this video, I'm going to distribute it as two sections. So the first section will be how to train and get a speech emotion recognition model. So, and for the second section will be on how I use the best model that I get from the section 1, and I can able to predict the emotion for upcoming audio data. So for this video, for your information, I will not go to run the code because the code takes sometimes around 1 hour to go. So if I run the code in this video, it take very longer time. So I will not using it. So for this video, I will just explain how I built the model and also can give you a tutorial on how you build the model. So for my case, I'm using Wave 2.0, VEC 2.0 to extract the audio file. So definitely the first step will be install the library Torch Audio and Transformers. So this is the library that I have to install to use Wave 2.0 VEC 2.0. Okay, so definitely I have to import the library. So for use the Wave 2.0 VEC 2.0, so I have to import this library. Wave 2.0 VEC 2.0 tokenizer and Wave 2.0 VEC 2.0 model. Later on, I will explain why I need to use it and this what is the purpose on this. So definitely I have to process my data first. So this step is just variable declarations. So tokenizer will be the variable to help me to tokenize the audio file by using Wave2 VEC2 tokenizer. Model this variable is just helping me to train the model and help me to extract the feature that captured by the input audio just now. So because for this data set, the emotions of the speech is labeled in the name. So this step is helping me to label the class. So this class will be helping me to input the data, tokenize the audio file, and extract the feature come out, and then I will for later on. So this I load the data. So this file folder path is the data source, data import. So for your future, if you want to train your data, you just change the folder file here. After that, definitely before I start to train the model, I will explore the data first. So for this case, 0 is 96. Other emotion is 192. That means the class is imbalanced. So it will impact my method to evaluate the model. So for this situation, I will decide to use a macro F1. So this is a function to help me to plot the waveform. This is a function to help me to plot the spectrogram. So yeah, this is the example for me to explore in waveform, and this is for spectrograms. Okay, before I start to train the model, I will split the data into 3 kinds of data: training set, validation set, and test sets. And then these 3 sets of data will helping me to train the model. So for this case, I will use LSTM model and also the other 2 traditional machine learning model. So one is KN, the other one is SVM. So yeah, let me start the step how I train the model. So this is a model that I train. So I will get the result will be like 0.38 for this LSTM model. So after that, I tune the parameter because sometimes the parameter will impact the performance of the model. So this step will be go to tune the parameter. So this is a parameter that I tuned. So I will get the best score will be 0.4618. The best parameter is this. Batch size 256 and epochs is 150. So I want to train the best model by using the model set. So the result will be like 0.47, which means it is differ insignificantly. So I will say that the model is no overfitting or underfitting issue. So yeah, the next step will be train another model. We call it a KNN. It's a traditional machine learning model, because just now we use the Wave 2.0 Vec 2.0 model to extract the feature come out. So the feature will be import in this KNN method. Okay, so let's say I set the n is equal to 5. So the macro F1 will be 0.2994. So I tune the parameter. Sometimes we get the better performance. I will get the best parameters in this, and the best score is 0.3073. So also I evaluate the test set also. So I will get the mark with the same as this parameter. So I will get the macro F1 is 0.2860. So I will say that compared with LSTM, LSTM is performed better. So the last model that I use is random forest, another traditional machine learning model. So for this model, I train the model first. I will get 0.3411. So I tune the parameter also. This is a parameter that I tune for random forest model. So I will get the best parameter is like this. The best macro F1 is 0.3696. And it will help me to evaluate the test set. I will get this 0.3435. So I will say that this model actually also have no overfitting or underfitting issue, but compared with LSTM, LSTM is better. So the best model is LSTM with 128 units, drop out 0.2, and best side is 256, epoch 150 is the best model. Then I save the model and name it as best model.h5. So the first section is finished. So I'm going to use the second section. Second section is help me to predict the emotion for upcoming audio data. So same as just now, I did write it all the code already. So this is a library that I use. So just one you want to alert is these two script just now. Just now I show you the script just now, and this script is better that you put it in the one folder. It's for you to easier to detect the model that you saved just now. So this folder path is just now what you save. So the script where you put, so you just copy the folder path and say put it here. So the last this is represent the model that you saved just now, the best model that you saved just now. So the data preprocessing was the same as just now that I run everything. And then the one more thing you have to alert is your audio file. So this file folder path is the upcoming audio that we want to predict the emotion. You just paste it and then you just run it. So this is the result that you will get. Predicted emotion from this audio file is neutral. This audio file, the predicted emotion is calm. So I will extract this emotion come out. So we can get the predicted emotion for upcoming audio. So yeah, that's all for me, and hope this lesson tutorial can help you. Yeah, thank you very much, Doctor.